Space Technology Center in Amity.
Namaskar, sir.
And we are joined by Dr. W. Salomurthy. He was the DG CSI DRDO. He worked there for 40 years. So, and
Namaskar, sir. Nice meeting you.
he was he is a
Which part?
chancellor of Amity University, Chhattisgarh.
Excellent.
He is the president of Amity Foundation for Science, Innovation and Technology also.
Excellent, sir.
Thank you, Subramanian. You are from
Thank
which part of Tamil Nadu? You are from Tamil Nadu, no?
Yeah, he is from.
Yes, sir.
Which part?
I come from a place called Kadalur, nearby Pondicherry.
Kadalur, yeah.
ஆமாமா, தெரியும் தெரியும். இது நம்ம கடலூர் தெரியும். பாண்டிச்சேரி
Kadalur.
பக்கத்து.
Nearby Pondicherry. Correct, sir. Correct.
Very good. Delighted. So you studied in which institutions?
I did
Trichy.
my things in REC Trichy at IIIT Bangalore and things like that. Yeah.
Oh.
Yeah, in
PhD?
those days it is REC, now it is NIT.
Yeah.
PhD is from NIT, yeah?
Yeah.
IIIT. Yeah.
IIIT.
IIIT. Yeah.
Good. Very good. So Kothari Sahab, namaskar. He is
Namaskar,
our
Kothari Sahab.
Vice President of ASTIF and
Yeah.
also in the Amity University, Rajasthan, we have a very distinguished role for him for research coordination. And Dr. V.K. Jain, he is a great innovator again from DRDO. He was in Solid State Physics Laboratory, SSPL, for almost 35 years. And he is a great innovator.
Yes, yeah.
And he is now the director for Amity Institute of Materials and Devices and multidisciplinary research. He is coordinating, a great innovator.
Excellent.
Prasad is heading the Amity Institute of Space Science and
Technology.
Technology. He is also from DRDO. So we have very distinguished people in this discussion today.
Wonderful, sir. Wonderful.
So now currently you are in research.
Subbu worked for almost 25 years in CDAC, and he was heading the R&D group and coordinating the R&D group from DG office. later.
Right.
Yeah, and after that, he is now taken over as the Executive Director of SETS. SETS is the organization under the PSCS office,
Right.
directly under PSC. So,
Like we had a
Subbu PC Saxena is also with us. He was.
Oh, excellent.
Yeah. So, but of course, his health is not permitting nowadays, but
Right.
we have given him honorary doctorate and adjunct faculty also.
Right.
So one good
Sir,
thing, our founder president is very visionary, and he has identified some stalwarts who are about to retire or retiring from the government and these national labs, and
Right.
he brought all of them together. So to
Excellent.
advise many people here, that is the
and
greatness.
working with young people,
Young people.
energetic faculties, PhD scholars.
And providing necessary guidance to all the people. So that is what.
Also Ramalinga Swami Fellows, Ramanujan Fellows, inspired faculties, Fulbright scholars. So we have brilliant, prestigious postdoctoral fellows along with our faculty.
Excellent, sir. I can make out from the way the institution is being led and its ranking and other thing. Yeah, absolutely.
I think we'll start.
I think we'll start, sir. So,
Right, sir.
yeah, I
So-
welcome Subbu for this meeting.
Friends,
Yeah.
I request our Dr. Salomurthy to say a few words and then we can start.
thank you so much, Dr. Murthy. First of all, I welcome each and every one of you who have joined us in this very important lecture on quantum and quantum related to cybersecurity, quantum key distribution, and all those related to the cyberspace. We have a very distinguished person to share his experience, expertise, Dr. N. Subramanian. who is the Executive Director for Society for Electronic Transactions and Security. And he's a very accomplished and high-profile director and scientist and technologist. And we are so proud to have him today in this lecture. And I wanted to inform you, Dr. Subramanian, that Amity has launched Amity Quantum Mission, aligning with the National Quantum Mission. And this was announced by our Chancellor, Dr. Atul Chauhan, and with the blessings and patronage of our founder president, Dr. Ashok Chauhan. And we have about 70 faculties plus who are working in quantum domain, like quantum computing, quantum sensing, quantum communication, quantum materials. So all these domains, including in quantum computing, the cybersecurity becomes a part of this as well. So we have a very strong group. Knowing this and knowing the importance of this field, so we have started a mission mode program in Amity Quantum Mission, and in which we want to also bring people like you to bring synergy, value addition, so that with your actual practical experience in MIT, CDAC, and also this certain, all this will be actually, you are the people who are practically implementing these programs, including quantum key distribution. Once we develop certain things, the application will be there. So we are also bringing synergy from experts like you to come and talk to us. What are the thrust areas? What are your experiences? Where should we give the thrust? And our people will learn from you and your deliberations. Then we would like to connect with you. It's just not only for the lecture, but we would like to also connect with you. And we are also connecting with the JCB, which is a key developing agency in DRDO. And since I served in DRDO for 40 years, and of which 10 years as Director General of DRDO, and I'm here now. So we are bringing that connectivity in JCB, which deals with the cyber security. PK Saxena used to be there in your PSA office. He is also from SAG and also JCB. So they will be one of the partners as well as collaborators. So we will also connect with them. So we bring such people, partnership, collaboration, synergy, knowledge sharing, and also guidance, because you people will be able to guide our team in a very focused manner on grounds. So this is the first collaboration, partnership, networking, and connectivity we are building with you, Dr. Subramanian. And later on, we will continue this, and all our faculties, we are connecting them to you, and we are connecting you to them, so that this will become a continuous interaction, so that the partnership and the dialogue which we have begun today will be long lasting. So I would appeal to all the faculties. We have such a distinguished person who is now going to speak, who will be introduced by Dr. Murthy formally. But it's a great opportunity to learn from him and also collaborate with him, partner with him, take his guidance. So that is why this lecture is very important. So with this, I welcome each and every one of you. And we have selected Subramanian, the top people in the organization, not only senior people, but young, energetic, enthusiastic, the scholars and the academic and research people who will be joining, who have already joined and also in the process of joining. So there are already some 40 people have joined and more will be joining as well. So thank you very much for accepting our request and invitation from Dr. B.K. Murthy. And I am also grateful to Dr. Murthy, who is taking a lead role in coordinating this quantum activities in Amity Group. And thank you for connecting with such people, Dr. Murthy. Now over to you. Please introduce him formally. And since we have worked with him, we have known him personally and professionally, and you will be able to introduce him better than me. So over to you, Dr. Murthy.
Yeah, thank you very much. Once again, welcome Dr. Subbu. So Dr. Subramaniam is Dr. Neelakantan Subramaniam. He is now currently working as Executive Director in Society for Electronics Transactions and Security, SETS, we popularly say this. And SETS is under the office of PSA and directly under the Principal Scientific Advisor to the Government of India. and he is heading this. Before joining SETS, he was the R&D coordinator, R&D in charge for the Center for Development of Advanced Computing in Pune. And he was there for quite some time, almost 10, 15 years. Before that, he was in the CDAC Bangalore side, dealing with the cybersecurity and then Garuda grid connectivity. That is one of the important contribution for him, where the resources of various computers, even before NKN started. So the grid was one of the thing that is his brainchild. It was set up at Bangalore and all the CDAC centers, where the computing resource centers can be pulled together and then connected into one, and then you can get the supercomputing or high performance computing facilities. That was one of his contribution. He did his master's degree from NIT Trichy. In those days, it was called RCE. During 95, 97. After that, immediately he joined in CDAC Bangalore. And his PhD is from IIIT Bangalore in cybersecurity. His main key interests are in cybersecurity, quantum security, post-quantum cryptography. These are the main areas. And SETS is one of the first organization where MIT has funded post-quantum cryptography. That is the first organization in the country who has come out with this proposal of post-quantum cryptography. Dr. Prem was also there. Later on, I will also bring him for a talk. So he is an expert in the post-quantum cryptography. So Dr. Subbu, okay, sorry, Dr. Neelakantan Subramaniam, we normally, when very friendly way, call him as, and he is popularly known by many people also as Subbu. So I don't think he will mind anything if any one of you call him Subbu. We all call him as Subbu only. And many people, even outside also, people call him as Subbu. And he is very good expert, hands-on person in cybersecurity, even at this level of distinguished scientist level at SETS Chennai. He is in level 5, level 15 or level 17. So still he is a hands-on person in cybersecurity area and quantum cryptography area, and he is publishing a lot of papers also. So before giving the platform to Dr. Subbu, I will talk about Amity University. As you all know, Amity University is having various, we call it as Amity Universe. It is not a single university. There are 12 universities within the country and 14 campuses and equal number of campuses abroad as well. So those many institutions are there. 250,000 students are there at any time in these campuses, and around 10,000 faculty and scientists and researchers are working in these areas. And more than 45,000 publications were there as of now in reputed journals or SEA index and even more than that. And we have filed more than 2,570 patents published. And out of that, 450 already granted. And there are, at any time, you can see that more than 500 R&D projects are being developed in various organizations. So that is the strength of that. More than 35 technologies have been transferred, and 450 patents were there. 4,700 designs were also, case studies also have been created. All this wealth is available. That's where founder president passionately creates a lot of missions. We work on a mission mode project. So for what most of the things, recent mission was added is quantum computing, quantum technologies. Earlier, we have a mission, space mission. We have mission, knowledge to wealth, and so many other missions, mission startups. So those things we are having it, and each one we conduct in a with a complete passionately and develop the projects. Our founder president says that success by compulsion. So that means if you are trying to do it and you will get succeed, there's no way of that you are failure. So that's where we are there. So without taking much time, over to you, Subbu. Please talk about the quantum cryptography, quantum technologies that you are doing it, and also tell how we can collaborate with you in various projects, how we can jointly create something. Over to you, Subbu.
Excellent. So, a very good evening to each one of you, distinguished members, and it's my privilege to join you here. I sincerely thank Dr. B.K. Murthy as well as the organizers for inviting me. Having known the kind of profile people who are joining here, I'm a little scared, to be frank. I'll take this hour. What I thought I would do in this time is that walk through gamut of things, what we largely what we do in sets, but slightly on the intricacies of what's happening at the national level and what are the opportunities that are there, because since we have academia and researchers over there, I think it will open up opportunities there. There will be multiple parts to the sections what I would share about, on just glimpse of quantum computing to communication to post-quantum crypto, and then the hybrid way of how these systems are kind of evolving slowly in the current context. So this is how I have kind of, and of course, touching upon at the end what we essentially do at SETS, and that will give a glimpse about what are the opportunity area for both of us to kind of collaborate. I'll just take a moment to share the presentation. Just 1 minute.
Yes, you can share it.
So I
Yes.
hope this is visible.
Yeah, just make it slideshow mode.
Yes.
Yeah, that's it. Yes,
That's
perfect.
Oh,
Yes, perfect. We are able to see this.
no, I have an issue. Just 1 second. Fine. Yeah. So, as introduced, Society for Electronic Transactions and Security is an organization under Principal Scientific Advisors Office. And we always proudly say that this organization was formed 25 years before by our beloved Honorable former late President Dr. APJ Abdul Kalam. And we have been since then guided by the president of this society, which is the PSA themselves. This organization was groomed and nurtured after that by Dr. R. Chidambaram and subsequently by Professor Vijayaraghavan. And right now we are getting all our guidance and support for Professor Ajay Kumar Sood. So yeah, with that, let me just the first part of the talk I thought we should just talk about is the glimpse of what's happening. So we know that the National Quantum Mission is very much unveiled, and there are a lot of technical groups that are formed. Interestingly, there are also the hubs that have been established, and what we call it as the T hubs, and then the subsequently these hubs are made to focus on specific verticals as quantum computing, communication, sensing, and materials and devices. And what is interesting to see is recently having onboarded several startups, almost like 8 of the startups have also been, industries have been onboarded. Interesting to notice that the way in which this quantum mission is being driven is as a multi-stakeholder consortium mode kind of an approach. So that's an opportunity for all of us to join together. So we are closely looking at the developments that are happening. Time and again, we keep seeing, even a week ago, there has been a lot of updates from Google as well as from China on the developments of quantum computing, which we all know that it's a new paradigm of computing that leverages the quantum mechanics principles and enables us to leverage solving of certain kind of problems in a more efficient way. And presently, it is believed that we are in a intermediate scale quantum computing era, and the fault tolerant stable coherent system is getting built, but I think it's foreseen there is one guesses about some 2030 to 2035, but then things are moving very rapidly now. Coming to the communication, good news is that there is a lot of advancement. You have technology readiness level beyond 6 and 7 in this space. You have a lot of QKD boxes available. So if today in the country we want to try out certain experiments, we can actually deploy these boxes and then for a limited distance, and then we can carry out quantum key distribution. Essentially, here the problem statement is to address the fundamental weakness in the typical TCP/IP or the internet kind of classical computer network scenario, where there is always this notion of man in the middle. So sharing of keys have always been a challenge even today. So traditionally, the way in which things have been addressed is through public key crypto systems. So once you use a public key crypto system, you have a methodology to share the secret keys, and that's how it is going on. But still, all the protocols that are existing leaves way for man in the middle in the current context. So quantum communication, with its fundamental capabilities of no cloning theorem, enables that information secure, theoretically secure system where you would be able to agree upon a key, and then that key can be used for secure communication purposes. So again, there are a lot of methods in which things are being attempted over here. Like in the quantum computing, you have various ways that one can realize the system. Here we have various primitives, communication primitives that are there, that is possible for one to achieve the quantum communication primitive. Now, when you look at the sensing, of course, we do less in sensing and in materials. So I do not want to really talk about it, because we know that sensing is much mature compared to all the computing as well as the communication. And there are a lot of sensors, including for measurement of gravity and time sensors and things like that, that are getting built, atomic clocks and things like that. So, and materials, of course, has been a separate vertical, which actually adds to development of quantum technologies and things like that. So this is how the National Quantum Mission is also cleanly compartmentalized into 4 streams. And SETS actually is very focusedly working in quantum communication. And to be very precise, even within quantum communication, we actually do work largely related to fiber-based QKD alone, because there is another stream of work that you see happening in the free space QKD. But we largely confine ourselves, I won't say confine, till today we have been doing a lot of things in the classical post-processing, which is basically the method that is required on top of the quantum key distribution state to ensure the keys are agreed upon through series of steps. So we are essentially good in implementing that in FPGA and things like that. So we are extremely strong in quantum communication for what we call it as post-key processing, key distillation engine, error correction, and things like that. These are our strengths in it. And I'll talk about it, what we have been doing and what is happening even otherwise in this space. Now, in the quantum computing, we are novice. We are very recently, in the last 1 year, we have got an opportunity to work with Institute of Science, Bangalore. With respect to the quantum communication, our team has been closely working with Professor Anil Prabhakar from IIT Madras, who is actually leading this NQM hub at which NQM IIT Madras come CDOT hub located at IIT Madras. So even before this, MeitY, Ministry of Electronics and IT, had developed a project called Makan. I'll be touching upon it, which actually brought SETS, IIT Madras and CDAC Bangalore together, and based on which we are carrying out this activity in communication. Now, as I said, I was talking about computing. Computing is something new for us. We are not physicists actually. We come more from cryptography. So we are very focused, and we do not want to kind of drift away to any other area. Largely anything to do with cryptography, cybersecurity related aspects, we are there and we would be interested. So here in quantum communication, our interest is more from the key distribution as a key distillation process, and then using it for applications like encryption. So that's clearly the role and contribution in that implementation of that in FPGA and things like that. Now, coming to computing, the new threat for us, having gained about 4 years of experience in doing the error correction codes, for quantum communication, we find the same opportunity to be leveraged for quantum computing as well. Not at the quantum mechanics level, but at control electronics aspects kind of a thing. So what we have been doing.
Subbu, you are still in the first slide, the same slide, or you are moving?
No,
We are not able to move that.
are
You are
you
not
seeing?
able to see.
Oh, you're not able to see anything.
Yeah, slide, only one slide we are getting. The first slide, the quantum technologies, that 4 areas.
Oh, no. I have moved to the second slide actually.
Okay.
Should I stop and again reshare? 1 second. Thank you for. You can see this slide. I'm talking about this slide.
Yeah, the quantum computing and all the 4 areas of quantum.
4 areas. Yeah.
Okay.
Is the slide moving? Can you? I'll just check it. Let me just check it.
Just go to the next slide then.
Yeah.
Yes,
Okay.
we are able to.
Okay, fine.
Yeah.
So in the quantum computing, so we have been under the NQM initiative recently started working with IISc headed by Professor Chandrasekhar. He is trying to build a quantum computing paradigm based on the photonics principle. So basically, we have been operating on the optics and for the fiber communication. Similar error correction methods may also be useful for us to work with them in this scheme. So this is what we are doing. So now let me move to typically when you look at the quantum computing, needless to say, I'm sure that you all would be aware of the primitives that is enabling us, giving the advantage, quantum advantage because of superposition and entanglement. This entanglement primitive is also applicable even in the communication primitive, but on the computing side as well. And then there are always various competing approaches to build the quantum computing. Superconducting is the one we all know that many players like IBM or Google or agencies like that. In India, we have TIFR Professor Vijay Raghavan trying to build a system based on supercomputing qubit. Similarly, spin qubits is very promising because the challenge what one would see in the superconducting infrastructure is you need to have a sub-Kelvin level cryogenics required for it. Whereas, in the photonics or in, semiconductor-based ecosystem, you would have those advantages over there. Similarly, trapped ions. So you see work done by Professor Umakant Rapol in IISER Pune approaches the problem more from trapped ions. Neutral atoms and photonics is very promising. As I said, we ourselves are working with Institute of Science Bangalore. Professor Chandrasekhar is trying to, devise the quantum processor with photonics principle. So again, this is having an advantage, like you don't have those constraints what you would have from superconducting qubits and things like that. Now, one thing that is coming to light these days is about this notion of physical qubit versus the logical qubits, right? So what's happening is when you see a lot of news items saying that there are we have built a 500 qubit machine or 1000 qubit machine kind of a stuff. What essentially are they talking about? Are they talking about the physical qubit? The reason is that when you see at the physical qubit level, there's going to be a lot of errors and noises. So more and more you see the convergence of the logical qubits, which are aggregation of the physical qubits, which are without errors that are over there. So when you talk about asking a question about what is that we are talking about quantum volume, which is essentially some kind of a measure to understand the performance of the compute system, we need to be very careful to understand the logical qubits from that perspective. And there are a lot of discussions happening on about the quantum volume. What are the parameters that you would use to assess the performance of a quantum machine? How do you compare? How do you evaluate? How will you benchmark and things like that? So these are some of the things that we see. Now, okay, what are the typical use cases one does see? So you see a lot of applications that are there from the simulation space, spreading across variety of domains from pharma to aerospace to energy and financial domains. Similarly, for optimization, you have use cases from finance, logistics, and insurance and things like that. Machine learning seems to be more, again, promising, where you have autonomous vehicles and fraud prevention mechanisms to be built, and see how generative AI and horizontal AI can get evolved under this. Leaving all these three from SET's perspective, we are actually very focused on the last bullet, which is written on there, is cryptography. So when you talk about cryptography in the context of quantum cryptography, you touch upon multiple things. You talk about quantum random number generators. You need to, because for any kind of a secure protocol, the entropy of the key, I mean, the randomness is very important for that. Similarly, when you look at the quantum key distribution mechanisms and methods for sharing the keys securely, then you talk about totally a different aspect, which is post-quantum crypto. Ideally, I wouldn't put it here, because when you talk about things related to quantum technologies, you would not want to talk about post-quantum crypto. The reason is, post-quantum crypto, though the name is post-quantum cryptography, it is largely to do with classical systems getting empowered or resilient to an adversary who's actually going to emanate from quantum system. So though post-quantum cryptography, I have put it because there is a lot of convergence that is happening. The way in which it is panning out is that you have a QKD system for key distribution, and then you have a post-quantum cryptography at the last mile, so that you have the entire quantum resiliency end to end. So you can have a wide area network and key sharing primitive, and for your local, for security to extend the quantum resiliency, you can have the classical systems padded with the post-quantum crypto schemes. And this kind of a mechanism is what is kind of being now experimented at SETS as well as at various other locations. So now, a snapshot of the current scenario, we see the rapid advancements at global level. We see from industry trying to build fault-tolerant quantum computing system. We see a lot of investment, especially I am given to understand the reports say that in 2025 there has been a surge in investment in quantum computing. It is also seen globally, there are clusters that are kind of getting set up at the US, UK, Europe, China, Japan, and of course, India right now. You see in the last bullet, which talks about NQM, 4 thematic hubs have been established. And these are the list of 8 industries that have been associated with many of these hubs over there. So I think we are very much there, but we need to see we need to catch up a lot in this space. Okay, so having just understood the glimpse of the terrain of what's actually happening over there and what's happening in the country and in the space of quantum computing, let's just get into the quantum communication aspect. So here, essentially, the problem statement is basically we need to have the keys to be shared securely. So the way in which it essentially works is that typically you will have a quantum channel, and then you will have a classical channel, and then the keys are agreed upon through the quantum channel in combination with classical channel as well. And the primitive of no cloning theorem actually helps us to ensure that any measurement or any adversary does in between will disturb the quantum states, and that would enable the other parties to know. And when they find the errors more, they will kind of back off beyond certain threshold. So that's the kind of principle under which this whole scheme of things are happening. Now here again, if you look at this space, you have from the medium point of view, you see free space and fiber-based QKD. In India, again, if you look at free space QKD, you see agencies like ISRO, PRL Ahmedabad, IIT Kanpur, and RRI, Dr. Urvashi Sidha and their team. They largely also work in the area of free space QKD. Fiber-based QKD, we have, as I said, under the leadership of IIT Madras, agencies like CDAC, SETS, and a few other agencies are getting added now into this consortia, and we have fiber-based QKD getting established for short distances. But the NQM mission also talks about a very long distance, say from Chennai to Delhi via Bangalore, Indore, and things like that. Here again, the challenges and proposed opportunities for research includes development of trusted repeated networks, because if you want to ensure the quantum key distribution for longer distances, you need to have trusted relays and trusted repeated networks to be created, and those devices needs to be developed. And quantum memory will be enabling these kind of primitives to scale up the distances and things like that. Again, if you look at this whole scheme of things, largely you see works happening in the country more on prepare and measure based QKD or entanglement based QKD. So this is at the quantum level, quantum channel level. And then when you look at the classical post key processing, there are series of steps involved, like sifting to error correction to privacy amplification, and these are the stages that are involved. So together, when you see the quantum channel and the classical channel, you kind of come to an agreement of a key securely and through these primitives. And as I said, the post-quantum cryptography augments this at the last mile, which got nothing to do with quantum mechanics, but then that is required for the classical systems themselves to be empowered with that. So if you want to put it this way, you have the quantum transmission either through prepare and measure or entanglement-based approaches, and then the classical post-processing stages that are there. As I was saying about key distillation engine, which implements the stack of things that goes inside, including the preparation of keys and sifting operation to understand the errors that have gone through and agree upon a set of clean keys that have come across. One of the commonly used since 1984, BB84 has been created, and this is one of the protocol which is based on the primitive of prepare and measure, where you see this is getting realized. So basically here the sender Alice, and then you have Bob, typically the receiver. So they kind of Alice generates a sequence of bits randomly chosen, and also the basis under which it is created are also chosen, and it is sent to Bob. And then Bob actually randomly selects the measurement basis and then records the measurement. And then this in the classical channel, through the sifting operation, they try to share few information and try to see whether the bases are correct or not. And for all those incorrect one, they kind of drop it, and then they kind of converge on the key space based on the privacy amplification to ensure this. What is to be noted here is that the adversary probably can be there in between, and if some Eve is there, and then if there is noise that is crossing beyond certain threshold, then both of them will kind of back off. So that is the kind of primitive under which the prepare and measure QKD protocols work. So actually, there are other range of protocols that implements it currently, like COW protocol and DPS. So at such we implement some of these protocols. Similarly, the alternate approach is through have an entanglement-based approach here, where there is a entanglement source. Typically, it could be housed at the Alice side or Bob side, but then there is a source that creates the entangled sources and then distributes it to sender and receiver, and they kind of carry out the operations for converging on the secure key generation. So when you look at both these methods are discrete variable methods, and there are other QKD protocols like continuous variable QKD and things like that. These are realized through device independent methods and semi-device independent methods and things like that. So these are from such point of view, and what we are doing is more from the prepare and measure kind of protocol. Now, let me just move to the notion of cryptography because, okay, so when we talk about quantum cryptography, when we talk about QKD, we also have to talk about the cryptography, because once the keys are shared, essentially you need to again have a scheme, a crypto scheme to securely communicate the messages, right? So the post-quantum crypto context goes back to the current era of classical systems, where we actually use either the primitives of symmetric key crypto system or the public key crypto system. So when you look at the symmetric key crypto system, it is it's been there for more than 2 decades. We have seen DES, triple DES, AES, right? And today you have AES largely implemented in all our browsers or all our applications, operating system, everywhere in the internet, and VPNs and things like that. The performance of AES is much efficient because of its inherent way in which this scheme works. And the number of bits required to encrypt the messages can be very smaller, to the tune of 256 bits or things like that. So it is very performance, very efficient with respect to performance as concerned. So only one challenge you have in the symmetric crypto system is obviously how do you share this, because here the keys are going to be same from the sender and the receiver. How do you share this key across the parties? So that's where we saw QKD. So QKD comes into picture. So once you have a quantum communication coming into picture, you have the keys generated. Then after that, you can always use this present day symmetric crypto system itself. So for example, if you are using AES, what is being said is that the current threats to the quantum, the current threat to the crypto schemes are not affecting largely the symmetric key crypto system, because even if you look at the algorithms like quantum algorithms like Grover's algorithm, which is about the large search spaces, you would be able to overcome it because it's you can just increase the key bit and then you become quantum resilient. So good news is that symmetric key crypto system that we are currently using is safe. So the good news is that once you have the quantum key distribution QKD protocol and the mechanism in principle, you can still continue. After the keys are shared, you will be able to still use the symmetric key system, symmetric key crypto system itself, and work with that. Okay. Now, in the current world, what is the challenge is that it's not just always symmetric crypto system. The way in which the current world without the QKD is operating is largely based on public key crypto system. So where you have the notion of public key and private keys being shared, maintained by both the parties who are going to communicate to each other. So this primitive is implemented in protocols like transport layer protocols like TLS, or IP level protocols like IPsec, or VPNs and things like that. So essentially what happens is that you use this asymmetry key crypto system primitive to share the keys, symmetry key securely, and then further on the encryption would happen through symmetry key crypto system. So this way you take care of the security aspect, that the concerns of how do you share the key securely addressed by public key cryptography, whereas the performance of AES or symmetric key crypto system can be realized. So this is how the current world operates. Now, what is the challenge? While we were talking about the advantages of quantum computing applications for simulation or for AML or for optimization and things like that, it also poses a challenge based on the seminal work of Peter Shor, 1994 work, which talks about a quantum algorithm that actually says that when you have a sufficiently stable quantum system, you would have certain challenges for existing asymmetric crypto systems like RSA or ECC, which are largely being used. So that means once that threat is there, it becomes very challenging, though we need to find a way, how do we circumvent it, how do you overcome it? So this is where the discussion of the post-quantum crypto schemes come to picture. So essentially, through what we are trying to do in typical cybersecurity is about ensure authentication. How do you ensure authentication in current day system? We ensure authentication through digital signatures. So when you have a public key crypto system in place, you have digital signatures, then you can be rest assured that authentication is in place. Now, how do you address confidentiality? You have schemes for encryption. So you have confidentiality achieved. Integrity through computation of the hash. And then non-repudiation is a legal primitive where the sender doesn't come and say that it is not he who did not send the message. So all this is guaranteed by the public key crypto system. So today, in the current classical system, you have the nice coexistence of these two schemes intervened together for all these purposes. Now, so this is what we know. So we know that in a typical, whatever I was saying is about the same key getting used in symmetry key And in the case of the public key, you have the sender trying to use the public key of the receiver and then encrypting the message so that the recipient alone will have his private key to decrypt it and take it. So these are the primitives that we are currently getting used. So this also we just was talking about it. So when it is foreseen that there's going to be quantum computers, and if it is being specifically also devised for cryptographically relevant quantum computers, then it becomes very challenging that there could be attack scenarios like harvest now decrypt later kind of attack. Already people, from the sensitive segments like strategic sector as well as banking and finance have this concern of what do we do about the current day data that is getting encrypted. The good news is that most of them may be using AES or the symmetry key crypto system. If that is being done and if the manner in which the keys are being managed are also secure, then I think is fine. Otherwise, if you are again, they are dependent on RSA or ECC, then they have a challenge. So that is the kind of the challenge what we kind of foresee. Otherwise, the AES seems to be absolutely fine. The symmetry key crypto system is fine. So now to this post-quantum cryptography, the field is more unlike the quantum computing or a quantum communication, which is coming from the physics world. This is coming from the math world. So basically, you talk about devising a crypto scheme which is robust or which is resilient to attacks even when one is in possession of a quantum computing. I mean, a stable or a very fault-tolerant quantum computing. So that is where this whole requirement of post-quantum scheme comes. So that means currently, what is interesting to note is that in the US, we have this NIST, National Institute of Standards and Technology. They have been conducting this competition for devising such a post-quantum cryptographic scheme since 2016. So this challenge, this competition has been going for so long. And what is interesting to note is that there were about more than 132 entries that were there for this algorithm competition from various mathematicians across the globe. So if you look at the 2017 call, they received about 82 teams from about 25 countries, and 69 were actually complete, meaning they did certain initial pruning and selected 69. And they considered them as the outcome of the first round of evaluation. And then the call for further announcement for again new protocol, I mean new scheme design of crypto was announced in for digital signature in 2023, which received again 50 such submissions across the world. And NIST evaluated various of these proposals. After more than 3 rounds of very detailed, open, transparent evaluation, cryptographic evaluation by various experts, the NIST has published in August 2024 3 of the schemes. So if you look at it, these are those schemes. Actually, they call it as FIPS 203, which is basically Federal Information Processing Standard. First one, what you see over there is for key encapsulation mechanism. See, this entire competition, what is interesting to note is that NIST actually does this historically always like this. For example, when you go back to history, even way back 20 years back for the symmetry key crypto system to standardize it, they opened up when DES was there, Triple DES was there. They opened up the challenge, and through this NIST challenge, the advanced encryption standard AES was published, I mean, as a standard. So once it becomes a standard, which makes our life easier, because systems that are getting interoperable across the globe, you need to have a common standard, at least in the civilian space. For defense communication or for any strategic purpose, we keep it aside, because for our discussion, we are largely confining ourselves related to civilian space. So standards-based approaches are the way that the internet, the current TCP/IP and the internet protocol is working. So following the same kind of paradigm, they announced this competition for NIST Post-Quantum Crypto Challenge since 2016. So these are the 3. The challenge actually was open for 2 purposes. One is for devising an authentication scheme, that is basically digital signature scheme, because currently you can achieve it through your RSA or ECC. Since these 2 are challenged, because any factorization becomes easier to be achieved by quantum computing paradigm. you need to find a different kind of a math. It could be lattice based, it could be hash code based, multivariate based, or there are at least 5 or 6 different techniques that have been found as potential candidates for devising such a complex scheme. So first one, the challenge is open for devising an authentication scheme. That means essentially the competition is to devise, the cryptographers have to devise a authentication crypto scheme for authentication. And that is a replacement for digital signature certificates in the current classical scheme like RSA or ECC. The second one was to open up for key encapsulation mechanism. This is required very much for secure communication when you carry out between parties, like when you use VPNs and things like that. So these were the 2 problem statements that were opened, where 132 entries were there, and 3 of this were actually published. So what you see, first one is FIPS 203, which is module lattice based key encapsulation mechanism. Now, what's originally this authors of this had kept the name as Crystal Skyber, which is what is now standardized now, right? And when you look at for digital signature, we are good enough to go with 2 different primitive of math. One is based on, again, the module lattice based approach for the digital signature scheme, which is FIPS 204. This was originally called as Crystal's dilithium. That became a standard. The other one is a stateless hash-based digital signature standard. What is to be noted is when the competition was going ahead, it has to be understood that even before they could kind of finalize one of the scheme got eliminated even at the final stages. So the point I'm driving is these schemes are pretty new. And though it has gone a rigor of evaluation and a rigor of, testing, still it is surprising to see that some of those schemes get eliminated even after such rigorous kind of rounds. Now, that is one thing to be alert of. So that means when you want to adopt this crypto scheme, so that means you are talking about replacing a 20-year kind of an algorithm, what you have been using with something new. So we need to be aware of this, number one. Number two, the second, when you talk about the authentication scheme, as I said, there is 2 different schemes. One is lattice-based and stateless hash-based. Performance-wise, when you look at it, the module lattice-based approach is better, right? The Crystal's dilithium. Whereas the Sphinx Plus is performance-wise very costlier because the size of the keys are huge and the digital certificate sizes are more. So for example, let us take a use case. Today, if you are using a RSA kind of a primitive or ECC, assume, because ECC must be much efficient today compared to RSA. So if you are using ECC, it has to be replaced with either one of FIPS 204 or 205 for authentication purpose. Now, how would you go about that decision? Right? So you need to see about the performance cost that you would associate with adopting this kind of a crypto scheme. So these are currently, though the standard is published, I need to say that it is going to take another 1.5 years to 2 years, work in progress right now in the NIST and in the global level to develop systems and to test it. The world of cryptography operates this way, that there are accredited labs across the globe where you give a hardware implementation of a crypto system, getting certified, tested and certified. For post-quantum crypto scheme, today it does not exist and work is under progress and it is expected to take another 1.5 years or 2 years. So we are still in the, in an evolving stage. So this is one thing we should be aware. Second thing is we should be aware of the ongoing, the rate at which, see, for 20 years, we have lived with this AES and RSA and ECC. Now, within this 2 years, you see these 3 schemes. And then on the right-hand side, I have written just about a couple of months back, they have also chosen Hamming quasi-cycle, which is published. Similarly, there is another standard which is coming up is FIPS 206, which is going to be announced maybe within a couple of months, which is Falcon for digital signature scheme. So things are moving very rapidly and fastly. So we need to be aware of it. So now when you want to migrate, these are going to be larger challenges. Okay, so now Okay, having said about these challenges, what do we do now? How do we go about, what is the strategy? Because one is at one end, we need to be aware that the quantum computing paradigm may take about 2030 is what generally everyone is expecting to be safe in the classical world till 2030. Anytime after 2030 to 35, quantum computing systems may probably be in place. And before that, we need to have some action taken. So basically, there are two things that we need to be worrying about from the cryptography perspective. One is about the crypto agility. So here, till now, as I was saying, you have built tightly coupled system. So for example, when I get a router or when I get a perimeter security device, it actually comes bundled with an implementation of RSA or ECC in it. So I know how to run the IPsec or a VPN tunnel. That's it. So I just configure it. Gone are those days. In the coming days, it's not going to be that simple, because if you are going to replace RSA, what is that you are going to choose? Are you going to choose Falcon? Are you going to choose Sphinx Plus? Are you going to choose Dilithium? These are the questions. So that means the manufacturer or the OEM, the developer have to implement the crypto schemes, all of this supportive manner, and in the manner in which hypothetically assume there is a challenge that after a couple of years from down the lane, one of the crypto system, what you have probably chosen, is found to be not that resilient or secure, then you should be able to quickly migrate to the alternate one. So that is the need for the crypto agility to be considered when you talk about adopting the post-quantum crypto scheme, because you need to replace this algorithm. In the future, it may happen that you may have to replace this algorithm and for adequate security reason, and you need to have quickly mechanisms for changing it. And these are not simpler ones, because I can give you an example. It was taking more than 10 years for the internet and largely the systems in the internet to migrate from triple test to AES. But now we cannot have that kind of a pace at which to migrate. It has to be quicker. Okay. Second thing that we need to worry is about the hybrid approach. See, now what's happening is, okay, there are two schools of thought. Some of them, the one school of thought is about I move from the current classical scheme directly to the pure post-quantum scheme. So that means I will not use RSA or ECC at all, which has been proven and existing for 20 years. Till today, it is still secure until we have not seen actual attack happening, but it may happen in the future. That's the worry. So should I directly migrate to this newer algorithm, which are getting just announced last month and this month? How do I go about it? So that concern is there if you go for a pure PQC migration, because once you choose such an algorithm, what happens? What is the guarantee that it is going to stay the test of time for some more so long? So then comes the alternate approach. Another school of thought is about hybrid schemes. So here you take a benefit of doubt. So you have the crypto scheme itself intervened in such a manner that you take a classical scheme, like you take one of the existing algorithm, and then you take the post-quantum scheme, and then you somehow create a blend out of it. For example, currently the TLS protocol, the for the key derivative function, they use this kind of a mechanism, use classical. Of course, one hybrid scheme doesn't mean always you should use one classical and one pure PQC. You can also have two post-quantum schemes also getting merged over there. So this is being currently discussed in the IETF discussion forum, and these are work in progress. There is nothing out there as a solution. So if you look at the IETF Internet Engineering Task Force discussion forums under post-quantum schemes for TLS, they talk about the upgradation for the current TLS with hybrid schemes. That is for the chem point of view. Similarly, on the digital signature point of view, that is on the authentication side. So, for example, if you are already using a digital certificate generated by RSA or ECC, now if you want to use pure PQC based approach, say Crystals, Dilithium, or Falcon, what you can do is you can take a message and then you can have the digitally signing it with Falcon, right? And then you will have the certificate generated by it. But then the challenge again is that, do I trust Falcon for now? Kind of a thing. So then there are methods today they are trying to do an R&D where you will be able to do a nested signature of using Falcon as well as RSA, so that you can continue, your applications will continue to work with current RSA itself. And whenever you want, you can always have Falcon coming into picture. So hybrid schemes are possible. right? And there are different ways in which these hybrid schemes are getting discussed at this moment, but these are not yet standardized. So IETF, ITU, X5.9, all these standards bodies are discussing at this stage, how do we go about this kind of scheme. Now, what is the impact for the current world? If you look at the hardware security module, if you look at any bank, or if you look at any transactions that are happening, financial transaction, it is all backed up, or even key transactions like our own Aadhaar kind of framework. They use hardware security module to keep the keys securely, and then you would be able to use it for your application. Now, this will have an impact on migration to post-quantum scheme. Similarly, the trusted platform module, trusted execution module, secure processor, crypto chip development, going up to the web browser level operating system, your transport layer protocols, VPN, and all that kind of thing. We need to have the impact that is forcing. So this is going to be a burning question right now. What is the strategy? How do we see this entire internet or our own applications and services migrating to newer schemes? So what we did at SETS is we had a consultation with about 40 plus industries who are from India and abroad. They all came to SETS, and then we did a brainstorming along with the Controller of Certifying Authority, an agency under MeitY. Together we did this consultation, and we found the necessity to come up with a report that talks about the strategy for migration, especially for dual signature schemes. So necessity for development of indigenous technologies, the importance of crypto agility and hybrid schemes, standards development, capacity building, and the need for crypto testing, evaluation, and certification. These are the things that we found that we have to quickly do it in the country. And then there are a lot of opportunities. You see a lot of new startups, companies coming up in this space, already there in the post-quantum scheme implementation in hardware and software, embedded system, IoTs, and things like that. So it's a huge opportunity space for young researchers to look at for innovation. Certain actually had published recently a white paper on how do you go about migration. They talk about the manner in which how it has to be published. So Certain actually talks about a 4-stage approach. They talk about the foundational assessment. So for example, if you look at an organization like a bank or SBI kind of an organization, if they have to migrate to post-quantum scheme, first is they need to do a cryptographic bill of material. So they need to know what are the schemes they are currently using. Is it crypto? I mean, is it quantum resilient or not? For example, as I said earlier, if they are already using AES, they don't have to worry about it. Just increase the key size and live with it. But if they're using ECC or RSA, then they need to actually be concerned about it and migrate to the newer scheme. So for that, you need to do a cryptographic bill of material, CBOM, what they call, and then you need to do certain readiness. As I was saying, if you look at the comparisons of the current standard protocol like Crystals Dilithium or Falcon or Sphinx, each of them have their own unique performance cost implications. So that would have to be experimented as a POC to know your application throughput. So for example, if you have a hosted application that is giving 1 lakh transactions per second for client transaction, that would be based on the current TLS protocol using, say, ECC protocol. Now, if you are going to migrate it to Crystals Dilithium, what is going to be? It may be to general thumb rule to at least looked at published report says that the performance cost would at least be doubled or tripled, 3 times more than the current scheme. So you need to augment it with larger compute and storage capacities and then try to migrate and things like that. So those are the things you need to worry about moving in the phased manner of it. And also the need to see at what stage you bring in the quantum key distribution primitive as well. As and when the QKD and the secure quantum communication primitive gets mature, you have it in place for key distribution, and after that patch up with the post-quantum algorithms, what we just now saw, 20345 or any of that, and then you have a quantum resilient end-to-end from for your communication. So this is a typical scenario, like, if you have a headquarters of bank between 2 data centers, if they are currently using a encrypted tunnel, assuming that they are using AES, so what you can probably do is you can have a QKD boxer sitting there, and then they can have the quantum channel to agree upon the key. And then once the keys are used, then you can put it to the VPN channel for your secure communication. So the post-quantum scheme comes for the VPN inside at the last mile, and the QKD comes into the key distribution. So this is how typically it is kind of foreseen right now. But these kind of experiments are yet to be carried out in a use case level. In a lab level, there are certain experiments done. At SETS, we have this test bed available. We show between IIT Madras and SETS with a spider spool of about 50 kilometers. We have this kind of an experiment done, and we have now getting some requirements from industry and user agencies like banking and strategic sector to see how do we kind of replicate it for a real world use case. So, that's where this is. Okay, so the final aspect of my talk is just going to give a glimpse about what are all the things that what we are doing in this space. One is that you would have seen there are certain quantum random number generator solutions that are already available in India. There are things available from industry. You saw recently, probably you've seen this STIC. There was a launch of that by Honorable Prime Minister from an industry. Similarly, there are QRNG developed by IISc Bangalore, CDOT as kind of trying to do an R&D of it. And then there is another QRNG being developed by IIT Madras. Most of those QRNGs are bulk optics based QRNG, whereas what we have done is basically on the photon short noise based principle. So you have the photonic chip available from third party, and then we have devised the entire scheme which is patented by SETS, and that mechanism in which it is done gives you the quantum randomness to it. In fact, the purpose of why we started doing this was to use this as a device or a circuit for any cryptographic application hardware, like a hardware security module. If somebody is developing a HSM, they can actually use this, embed it into their architecture. That was our original goal. Interestingly, in the journey, we found last year we got certain requirements from the industry, like blockchain players. There are a lot of blockchain players in Bangalore and Bangalore. They kind of approached us and said that they actually, for their own application, they need random seed. So what they said is, why don't you make it as a hosted service, like typically like an Entropy as a service. So currently, what we have been doing in the last 6 months is we are actually have an API based approach and hosted this QRNG, and already 3 of the industry is kind of consuming it as a POC right now. And we are now talking about how do we scale it up for productizing it and then scaling it up for commercial translation to commercialization. So this is one thing that what we have been doing. Of course, this has been tested with all typical tests for randomness and things like that. The other important initiatives by MeitY, this is what Dr. Murthy sir was also talking about. Last 4 years, we have been doing this Metro Area Quantum Access Network. This is between instead of IIT Madras to SETS Chennai. We have this quantum channel established. And we have these partners. This is led by IIT Madras, and partners are CDAC Bangalore as well as Thiruvananthapuram is involved. ERNet and NIC are involved. SET's contribution is essentially, as I said in the beginning, we actually operate in the classical post-key processing space, basically development of FPGA, implementation of the key distillation engine in FPGA. That is our core strength in it. So as I was saying, it implements all those series of steps involved for agreeing upon, selecting the key, right? You have the shifting operation to, error correction to privacy amplification. All these methods implemented in the FPGA. So that's what is our strength in it. And what we have done is that we have done this KDE in such a manner it can be customized for any protocol of QKD, and not any, I should be careful, for any prepare and measure kind of protocol. Like for example, COW or any variant of BB3, BB84 and things like that, you can kind of customize it and quickly use our KDE for that. In fact, we have also tried to work with IIT Kanpur to see whether the same KDE can be customized even for a pre-space QKD. So we have tried to abstract out those functionalities irrespective of the medium of communication for it. So that's what is our work under MeitY. Now this, if what you see the box over here is the indigenous box. It has the quantum mechanic component and the photonic sources implemented by IIT Madras. the KDE is implemented by SETS in FPGA. CDAC Bangalore implemented the protocol, the QKD protocol itself. So this is how this box actually consists of IP from all these three agencies, and we have some kind of an agreement in IP sharing in this. And currently, Professor Anil Prabhakar is talking to industry to see how do we translate it to, because we have been doing this POC between institutions here, and we now want to take it to the next level for any real world use case and through industry partnership. That's what this current work is there. Now, this work actually gave birth to us to this next initiative, which is basically called KILA, which is Quantum Internet with Local Access. So again, this is the same consortium players, but new players have already been added. This is in the last 6 months under the NQM that is going on. So here we have objective is to build a terrestrial quantum network between Chennai, Bangalore, Hyderabad, Indore, going up to Delhi, beyond 2000 kilometers with newer protocols, what we have not done in Macan. And then also important thing is about security testing, because see, what's happening is now, at least in the quantum communication space, we have started seeing boxes coming out with some level of technology readiness level. So you need to have teams to kind of evaluate it. Like you would know already, since you are working with agency like JCB and SAG, there are requirements from such agencies to see that how do you evaluate quantum communication primitive or a box. So that is one important work package in this thing. And towards chip-based solutions based on photonic and electronic integrated circuits, indigenous and interoperable hardware, and quantum security as service, basically for encryption, digital signature. Quantum money is a very interesting primitive. Actually, we have another team, like what Dr. Murthy said. We have actually two teams working in this in these technologies. One is we have a team by Dr. Prem Lakshman Das, who is heading it. He is coming from math and more on the cryptography and post-quantum scheme. Then we have Dr. Natarajan and team. They come more from the physics side, more on the quantum communication aspect. Now, these two different teams have to, I mean, they operate, they converge on some of these research projects. There is actually something, an opportunity, I think very less people operate in the country is on the areas like quantum money, which is basically on quantum cryptography itself. So this is a very long drawn, I mean, it's a long-term research kind of a thing, where there are certain interest Dr. Prem has in that area. Currently, it is a very theoretical work. You at this stage, you won't talk about system development. You're talking about scheme devising and kind of stuff there. So this is how KILA is foreseen that ultimately after it's a 7-year kind of a roadmap. Right now we are in the end of first year. I mean, I won't say end of first year. We are in December now. Yeah. This is the quantum lab, and this was we had a separate infrastructure created with all this indigenous technologies and things like that. And Honorable PSA inaugurated it in the last Foundation Day 2024. DG CERT was also there, and these are the infrastructures what we have. So again, a summary of activities of SETS. As I said, there are two teams. One is cryptology and computing. That team actually is focusing on post-quantum cryptography, privacy enhancing techniques. So this is another area of totally a different area of work, not related to the topic what we discussed today. So when you talk about privacy enhancing schemes, you talk about zero knowledge proof, you talk about federated learning, you talk about homomorphic encryption, right? So there are various secure multi-party computation. These are different schemes, crypto schemes, basically for data security. So how do you have two parties share the data without sharing, without revealing the data? How do they share? So we have some lot of interesting work happening over there. And of course, in public key cryptography, whatever we have been doing on classical crypto, we have all migrated. For example, we had our own indigenous CA solution. It's a certifying authority solution. For example, for your enterprise, if you have a HRMS management or ERP management system, if you want to do a digital signature, you need this kind of a CA for it. And we have actually enabled it to become also empowered it to be a post-quantum CA as well. So these are the things that's happening in the cryptography and computing space. And of course, we are an important player in the blockchain, national blockchain ecosystem, which was initiated by Dr. Murthy himself when you were there. So that projects are glad to share with you. Probably you would be aware that it is already launched in last September, and currently there are 17 central government applications of importance like DigiLocker and judicially applications and things like that are already onboarded. SET's contribution in that is the blockchain, what is being hosted in the NIC and managed by CDAC Hyderabad. The core crypto component of identity management of the Hyperledger fabric was actually removed, and then SETS has incorporated our own crypto scheme in it. So the national blockchain framework has the indigenous implementation of crypto solution by SETS. So that is what there we work with IDRBT, CDAC Hyderabad, NIC, and IIT Hyderabad and Triple IT Hyderabad. Now, coming to the quantum security team, as I said, under the NQM, we are in scaling up the activity of Macan to Kila. We have products and solution developed for quantum random number generator, post-quantum VPN. This is another flagship thing. Actually, 2 years back, we have been very successful in rolling out our VPN for the defense forces. And very glad to say that we have a stationed on-site support at Delhi, and we have team sitting over there. Been used by agency even in critical times when it was required. More than 40,000 devices are using it. Now we are actually going to roll out the post-quantum version of the VPN as well. Similarly, the CA kind of a thing. Now, coming to what we do apart from these two teams, you can see on the right-hand side, the two other teams what we have in sets. One is on hardware security. Here we do two kinds of activity. One is what is called a side channel analysis. So, for example, if you have a standard crypto system, like for example, if you have implemented AES in a box, now you might have chosen a crypto system which is standard, but then while implementing, you might have made it weak, right? The implementation security aspect. How do you test it? So you need to have mechanisms for carrying out those testing. We have those equipments. You need to do a power trace analysis or EM radiation and things like that. So that is one stream of work what we do. So testing and evaluation of crypto implementation in hardware and microcontroller and FPGA and all that stuff. That is one thing what we have. The other thing what we do is slightly confidential, I mean, very much confidential, which is more to do with hardware security analysis of devices and things like that. The other team, what we do is on network security. This is the team that rolled out the VPN, and they are working on the CA and our own security event management system and things like that. So that summarizes the kind of activity what we do, and we largely almost like 80 to 85% of our efforts are more in product development and research. 10 to 15% we involve in our self training. Right now, there is a training ongoing for blockchain and network security. A week ago, we typically do a 5-day kind of hands-on training on this technologies like quantum security. We did for 5 days, and similarly for hardware security and things like that. So I think this summarizes the scheme of things what we do. Yeah, thank you.
Thank you a lot. It's a very, very informative lecture. A good round of applause to Dr.
Thank you.
Subramanian Subbu.
Very good.
Yeah, very impressive work that you are doing, and good that you are taking into a logical conclusion the project which I have initiated. So, and taking it to the nation, that is very, very, I mean, appreciable. And a quick, some of the questions from various participants.
Yeah, I'm seeing it in the chat window. One is, hi all, anyone wants to ask question? Okay. One of the
Dr.
questions,
Ashish Mani, there was a question.
Yeah, what happens if the QKD gets compromised by Eve? Do we simply abandon it, or are there any measures that can be taken to overcome it? I think there are, I'm really sorry. I don't know whether I can take this question, but I'll try to answer. My answer to this is, basically, when you have a prepare and measure kind of an approach, there are certain noises that gets introduced, and inherently the way in which the protocol works is that it backs off. So if it is beyond, say, certain percentage, like 30% of thing, then you back off, you abandon it. That's what it happens. But then there are approaches that are now evolving using entanglement-based approaches, which are much more efficient to make it more robust. And there are newer protocols that are coming up, which are even solving specific attacks For example, using beam splitter, when you have multiple photon sources coming, a man in the middle to take the copy of it and then taken by Eve, and those kind of attacks are all trying to get addressed. So there is a lot of work happening, is what I can say in this.
Sir, just to add in this, my name is MS Prashad.
Yes, sir.
Subramanian Sahab, I met you long time back. We will come to that separate. What is
Yes.
happening in FIPS 104? I am one of the member. We are
Excellent.
writing a protocol for this, that if the key is lost, which is very,
Common.
probability is very less. Then what happens, as you said, we will keep a copy or a second key will be sent with a different number.
Okay.
So
Oh.
that's the protocol already being read in that. Thank you.
Yeah.
Actually, when
Thank
you are creating a keys, there are 5 keys normally it is generated. That is a normal policy. So
Okay.
out of that, anyone is compromised, immediately the next one is used. So that is a
You are
norm.
right. You are
Second
right.
thing is,
Actually,
yeah,
yes, you are right.
yes.
Absolutely right.
Yeah.
Yeah, please go ahead, sir. Yeah.
Yeah. Second thing is, in normal, when you are talking about the quantum key distribution, even if the key is lost, okay, hardly it is very difficult for any person to encrypt using that key. So if it is compromised also, it is very difficult for other person to encrypt it, because the entanglement and superposition, these things need to be established on the qubits. It is difficult because the copying from one to other is not possible in quantum mechanics.
Correct.
Go ahead,
Absolutely.
please.
And
Any
the way
other
in which,
question?
the way in which the quantum channel operates is this: continuously there is going to be this process of key generation, material getting generated happens. So that can solve it. And quantum materials is, I said, we don't do anything related to that. Also in sensing, we know only quantum communication. I touched just some glimpse of computing. Also, we don't know much, to be very frank. We know only cryptography and some bit of quantum communication. Yeah.
Any other questions from any people? So Professor Prasad, Professor Anil Kumar, Dr. Anil Kumar, any question?
Good afternoon, Dr. Subramaniam. I must
Yeah.
compliment you. That was a great lecture.
Thank
You
you, sir.
talked about all the verticals, but the cherry on the cake was quantum encryption that you spoke about. And your work on QRNG and especially developing the network. It was an eye-opener. And I think all my colleagues who are dealing in this kind of work, Dr. Shalini, Dr. Rajiv Pandey. Dr. Rajiv Pandey, incidentally, is our faculty, and he's part of a DCC committee for quantum communication. So we're working on protocols, we're working on a hybrid post-quantum communication, basically combining blockchain with coronagraph techniques we are working on. But I think your inputs are going to be extremely, extremely useful to us once we write a project on that. Thank you very much, sir. My greetings from Amity University, Lucknow campus. We also have a team which is working on quantum machine learning algorithms. Basically, we're working on optimization algorithms on routing of maritime and air traffic control. We have a small team working on quantum communication and quantum materials we have. We are working on quantum dots, graphene-based quantum dots. And of course, we are in our own limited way, we are working on quantum encryption.
So I will
Thank you very much.
I will connect with you to Umakant Rapal, who is working in IISER Pune. Quantum dots, they are working, quantum materials also. Next time
Thank you so much.
I'll get him for another lecture next time. So
Yes,
Subbu,
sir.
there is another question from Shalini, Dr. Shalini Agarwal.
Yes, I'm seeing that. So
I-
there are any consensus algorithm need to be explored. I think
Yeah.
to me, it appears consensus algorithm largely is related to blockchain kind of framework.
Yeah.
That is being done by IIT Hyderabad under the National Blockchain Initiative. So I'm not very sure whether that would be in this context. In the case of even privacy enhancing schemes may be applicable, but I'm not very sure whether it will be
In quantum computing, consensus algorithm does not arise. In blockchain technology applications, that is there. And if there is anything is there, we can work out. There is another question from Dr. Shivani Verma.
Yeah, when we are trying to implement QKD and FPGA, how can we take care of resolution required or clock? Yeah, that's a challenge. See, there are multiple challenges to be very. I didn't talk about the challenges what we face. Actually, though this fiber is the problem statement MIT given to us was, they said that you should not, you will not be given a dark fiber. You need to live with the existing light fiber because that's what the world is already having. You will not.
Mm.
That's a very cost prohibitive approach. So first of all, the noises are extremely high when you have this quantum sources, single photon sources emitting, right? So that is itself is making our life very challenging to ensure the throughput what we kind of get, number one. Number two, the standard fibers are so noisy in a given 24-hour period, actual key material time, what we could obtain is say on an average about 8 to 9 hours. That's all. So total hours we could make it stable to get the key material. So those are larger challenges. Now coming to your question about trying to implement FPGA, it's see there are different levels at which this box what we showed. There are the single photon sources and quantum mechanics that are there which are implemented by IIT Madras. And then you have the FPGA. FPGA largely implements only the shifting, the classical post-processing. Basically, the shifting and privacy amplification error correction technique that is implemented in FPGA. But yeah, I mean, there are quite a lot of challenges. Absolutely. Yeah.
I have a very, very basic question. See, in the classical thing, I mean, when you are copying a original and then copy, it is the same on a classical computer. So copying is so easy because I mean, you can just tap the voltage level from the flip-flop and then connect to another flip-flop, it will get into that.
Correct.
So it will set and reset can be done very easily. So copying by bit, very easy, and it is original and then copy also will be same. But such copying is not possible in quantum computers.
Absolutely.
So in such case, why the security of encryption and all these things will come into picture? When I'm sending any communication using photon-based, single photon-based communication, if we are doing it, or even teleportation, that copying will not come into picture.
Copy will not come, but only the threat model generally when they talk about this QKD protocol, they always imagine two things. One is that they will assume that the classical channel that you are using along with the quantum channel, the classical channel is always an authenticated quantum channel. That is one assumption. Second thing is in the quantum channel, they will assume that there is always a presence of an Eve, because that's the threat model. Once if there is a third party involved and if she is able to tap in, meaning what it means is that you are right. The question is it's not about copying. It is about the quantum states. It is possible for them to infer.
Okay.
So those are the assumptions. Yeah.
Okay. Okay. Okay.
Sir,
there is one more question from Dr.
Sir, the
Subramanian.
assumption is, Dr. Murthy,
Yeah.
the assumption is you are 100% sure that we are not copying anything.
Yeah.
But the problem is quantum states.
Yeah.
You know, that can be copied or disturbed.
Mimic it. Actually, mimic. It can be mimicked.
That's the basic doubt. And that's why we are doing it. But to be very frank, Dr. Subramanian will support me. The entire concept of quantum encryption is because you can use a large amount bytes of encryption key which can be decoded very easily.
Yeah, very easily.
See, I designed some 16,000 bits RSA, but it goes on to Craig's MP to decode. But here it is faster.
Correct.
That is the most important part.
Yes.
Correct.
Thank you, sir.
Thank you, sir. And one more question is there. It is about this we talked about in the when I was talking about the something called as cryptographically relevant quantum computers, CRCQ, what they say. It is believed, it is sometimes somebody believes that it's already there. And so when you have a data right now, if it is already harvested, there are countries which are harvesting the data and then they'll be able to decrypt later, kind of a thing. It's already, that threat is there always. So that threat is always there. So in fact, the banking and financial or strategic agencies, they have real concern about this. So my answer to that is, those agencies should go inside and see what cryptographic primitive they are using. If they are using symmetry key crypto system, nothing to worry. Only step they need to do is increase the key size, double it, and then live with it so that it is secure even when you have a quantum computer, because as of now, symmetry key crypto systems like AES are not threatened by quantum computers. Whereas if they are using the RSA or ECC kind of asymmetric crypto system, they need to, as soon as possible, on priority, migrate to the post-quantum schemes like Crystals Dilithium or Falcon or Sphinx or things like that.
So, I mean, one more thing I wanted to mention to you is that now the big picture comes into this one, how we can collaborate. Okay.
Right.
I request Professor Prasad if he can have some views. I will talk about it later, my views, but
Thank you, Dr. Murthy. Thank you, Dr. Subramaniam. And it was a really very nice talk.
Thank
After
you.
a long time, I have heard the entire, field of cryptography and all, because I used to work on this. Very nice. And we can contribute. You see, specifically my team works for a space, but I would like to touch base with you on
Sure.
free space communication encrypted with quantum communication, because quantum communication does not do modulation and all. It's always a encryption. So we can come out and work with you on key management. See, this is one of the open question, that how do we manage the key in the large network? Eventually, all quantum communication will be as a graph and node-based repeater system, because we
Right.
cannot maintain the coherence for a very long time. So
Right.
my request is we can collaborate on this. We are also working on producing, quantum, this random number.
Okay.
My colleague have used some chaos theory to generate random numbers, and we are trying to put it on a circuit, and Dr. Murthy is enabling us with the IBM systems, and we will try, or even a CDAC system. So we will try and run into that, and we can always collaborate in that quantum random generation. One thing is there, we can work with you on protocols, because that's the most important part in our this thing, that people are just thinking this, so we can work on that. One of my students is working on lattice-based or graph-based computation. See, instead
Okay.
of lattice, suppose I use the graph,
Hmm.
take the points as the graph, connect it as a NP hard graph, then
Right.
can we do it? So I'm not able to tell you the solution right now, but couple of these fields we can always work out. And if you want that some people to work on alternative to Shor's algorithm, there are possibility, because in between, if you go through algorithm, there is a possibility that if he changes to another circuit, it may not give the same result. These are the areas which we can always work it out. Blockchain, you want the blockchain to be established by the software, and this, we are with you. And it was really nice. You may not be remembering me. I was very young at that time when I met you in CDAC. And with another Neil Kantan of DRDO, if you remember.
Okay.
Anurag, he
Anurag.
was in
Anurag.
Anurag. Yeah. At that
oh, you
time.
might have met him in Bangalore. When he was in
So,
CDAC Bangalore, you might have
Bangalore.
met him.
so
Along with
that's
Dr.
right.
Sarath was the ED at that time.
Correct.
Ah.
Dr. Sarath Chandra Babu was the ED at that.
Correct.
So that time I used to have black hair.
Nice. Thank you. Thank you. Thank
Nice
you so much.
seeing you after
Nice.
such a
So-
long time.
So Subbu, we have 3-4 opportunities of this one. Your campus is very beautiful campus. You have a nice guest house.
Correct.
So if some of the people, our faculty members during the lean period for a 3 or 4 days or a week, if they can come and then work in your lab, will it be possible? Or your team members can deliver some lectures continuously for 3 or 4 days, just like an FDP. Not just an FDP, but what I will say that
We make
hands-on to some of
FDP.
the faculty members.
We make FDP, doctor.
Yeah, FDP, and then we can at least 3 or 4 lectures, Dr. Prem and then Natarajan, they can come and deliver lecture, or you can have it in your own place. That would be much better, because you have a lab also, which is working.
Correct.
Quantum photon chips and other things are there. So I'll identify some faculty members from our side, and if it is possible, what are the possibilities for you?
So
And
the answer, I'll note it down. Yeah, right.
and
Yeah.
second thing is that how we can collaborate for joint research, and we are also planning to launch quantum computing courses, quantum technology courses. So in that course, for the faculty development as a course material also along with that. So what type of courses that are required? There we need your support. And then finally, is it possible to have an MOU with you also in the long run for doing all these things? So
I
that
will
is from
send you
my
the
side.
course
We can discuss.
details also.
Yeah.
Dr.
Yes.
Subramaniam, with the
Ah.
help of Dr. Murthy, I will send you the course details. You know, I
Yeah.
have kept a total paper of about 45 hours on quantum cryptography and communication.
Okay,
So
excellent.
in those areas that we need your support. And one more thing is whenever you are coming next time to Delhi, make sure that you are coming to Amity University. So
Sure.
we'll try to arrange. Just give us 3-4 days in advance notice whenever you are booking your ticket, and keep yourself at least for half a day separate so that you can come here, meet various people, see our labs, and then what we can do together that you can do it. And
Sure, sir.
yes,
Definitely.
and of course, whenever you are going to Bangalore, we have a Bangalore campus also, Amity University. So they're
Right.
also doing a lot of work in this. And
Murthy, can I ask you a
Murthy,
question?
Dr. Neeraj
yes,
Sharma.
yes, Dr. Neeraj.
Yeah. So, Dr. Subramanian, could you also tell us any call for proposals, etc. This SETS, your society makes under the aegis of you are under PSA office, na? Right?
Yes,
Yeah.
yes.
So, are there such opportunities available to our researchers? Are there any
So
calls for
we,
proposals for research, etc. Coming from your end?
no, we don't. We are not a funding agency, so we cannot do that. But we
Okay.
participate collaboratively for such calls, but done by DST or MIT. So DRDO, those opportunities are there. But we ourselves are not empowered to make any call for proposal kind of
So
a thing.
you all get your financial support, etc., from the PSA office.
We are actually, let me talk about our team. So I talked about the big picture. We are I always say we operate like a startup because we are exactly 16 scientist organization with 85 project staff typically, and very focused. That's why we generally don't drift to any areas, very particular about those things what we talked about. And we get their support from the PSA office, that is from the cabinet secretariat itself, for our core grants. But along with that, we also do a lot of, currently we have about 10 to 12 projects going on, some 6 or 7 from MIT and 2 from DST and DRDO and things like that. So we operate on project mode. But recently, in the last 2-3 years, what personally I have been trying to drive is more on the productization. So actually to push it out of the lab to see that it has a marketplace and roll it out and make it work. So one is we could do is on the VPN, the CA software, the security solution for IoT and all other things. There is another area of product that there are 2-3 products that we are working. Some of this product development we do even as an internal R&D. We don't get funds from anyone else. We actually fork certain projects
So can you
internally.
involve some of our scientists? I can see Professor Anil Kumar. He is doing a great job in Lucknow campus. Professor Prasad, Dr. Shivani Verma.
So,
there are many of them who
yeah.
are working in this domain. So if they get an opportunity to work with you in some of these projects.
Yeah. So the way in which we generally do is, I'll go one by one. What Dr. Murthy was saying is, one is about the FDP related thing should not be a big deal, because what we do is in a year, at least once, sometimes twice. In fact, about
So those are
a month
doable things.
ago,
What I'm saying is something beyond that.
Yeah. No, I'm coming to his response to whatever he talked about. So the FDP thing, what we do is that we actually do this 5-day hands-on quantum cryptography training.
Okay.
And usually this is attended by SAG, DRDO, CDOT, ISRO, kind of people, and few industry people also come. Rarely from academia, I should say that, but I think we should add you on to that. So that will be very intensive. It usually starts in the morning at 9 o'clock and goes till 7 o'clock, and mostly should be residential. We have here, and we don't take many. We can't handle beyond.
Yes, I
30 or 30.
attended one of them. Yes.
Yeah. So so we just did about a couple of months back for quantum. Similarly for hardware security. So I think that's not a problem. I think that we can definitely look at it. Second thing is joint research. The only challenge is, why I talked about sets is that, see, we always go work along with IIT Madras for the quantum communication, because what has happened is under the NQM and under MAITI, both DST and MAITI, IIT Madras has been made as the hub. So Dr. Anil is very much approachable. I think we can definitely what they call it as that 7-year roadmap in the Kila, there will always be opportunities for institutions to contribute. I think that is one thing that we should see how do we can jointly work on that. And I think support on the Dr. Natarajan and Prem are the two people who are technically very, and one is Forum. 3 of them are there. So I can connect with them with you. So for all any other, syllabus and all other things. I don't know whether I have not seen it. I heard that the NQM themselves have prepared a reference quantum course.
Yeah, we
material.
saw that.
Okay.
UGC has prepared it. UGC
Okay.
ICT has come.
Okay, fine. So those people can do it. And with respect to MOU, we need to just get the approval from the PSA. Otherwise, that is doable, not a problem. So I think, and we have something called internship scheme called STARS, which is available in our website, which has about 28 problem statements we have given. So any of your researchers, we generally have researchers who are PhD scholars or JRFs coming to us. So they spend time with us for 4 months to maximum we entertain till 1 year, but minimum for 4 years they should be there. We don't entertain beyond that. Now we are also soon going to come up with the paid mode of that as well. So we get a lot of candidates from DIIT students and from Pune and things like that. So I think that is also there. Yeah.
Okay. One more thing is, very soon you please connect us with Professor Prabhakar also. We'll have a meeting at the high level meeting, what we can do together.
Yes.
And how we can join in the IIT Madras hub.
Sure,
As
definitely.
a quantum. That you can arrange in the next week or maybe in the couple of weeks time.
I will
In this
text
month
you
itself.
immediately.
Yeah,
Yes.
talk to Prabhakar. He knows me, but still.
Yeah,
It is
sure.
better. Long time I spoke to him.
So thank you, Dr.
Now,
Murthy.
Dr. Salumurthy sir, yes.
Yeah, thank you for bringing such a wonderful person for this interaction. I learned a lot. And also the way you coordinated and the right kind of strategies to harness this connect and potentials for synergy. I must appreciate Murthy first. And then Subramaniam, your expertise, the way you are serving the nation in this field of cryptography, cybersecurity, and these are all amazing. And we must deeply appreciate your contributions at the
Thank you.
national. But we look forward to work with you, and as Murthy has defined some areas for collaboration, we will keep contacting you, and please do help us in terms
Definitely.
of building this, because we are building the capability and capacity in Amity in this quantum mission. So that is why we have already a nucleus of expertise, but we want to expand it, and we want to start capacity building programs. So maybe that we can jointly do some capacity building program. Part of it done there in your
That will
place,
be
and part of it done here. So I think there's an ample opportunity to start working together. I think, Murthy, we will start with at least one FDP program quickly.
Yes, very quickly we can do that.
That can easily be started. And also, if you have some people in mind, Dr. Subramaniam, if you have some people whom you feel can join Amity, when they are looking for opportunity, but they are really experts in the field, because you may be coming in contact with so many people, or even some of your own fellows who are working in cryptography in your
Some of
place.
your project staff can come.
I understand.
Yes.
Yeah.
So,
Yeah.
but they must be really very highly talented people, because we would like to build this core group and keep expanding. And because we would like to be a major contributor in the field of quantum technologies. So that's where we will need your help to build that capability here in terms of human resource as well. So that also another request I have. And I thank you very much for this wonderful lecture, and then very lucid, very, very well knitted presentation. I learned a lot. I enjoyed. Thank you so much. I'm sure all my colleagues would have enjoyed the presentation, interaction, and we will continue this interaction, Dr. Subramanian. Thank you.
sir.
Thank you so much.
Thank you.
Dr. Neeraj
Thank you.
Sharma, you want to say something? Dr. Neeraj?
No. I have covered my points. Yeah, thank you.
Okay. Thanks a lot.
Thank you,
to
sir.
Take your leave,
Thank you.
and we'll be in touch with you. So next time when you are coming, you should ensure that you are coming to Amity.
Definitely, sir. I'll be in touch with you.
Okay.
Thank you. Thank you so much. Thank you,
bye.
everyone.
Thank you. Bye bye. Thank you, everyone.